Hello.
Yes, madam, your screen is visible.
Okay. Thank you, one and all, once again for considering me for this. Here, for this talk, I have considered the topic that is related to the wireless body sensor network. Now, we all are moving towards the fifth generation, sixth generation research has already been started, and people are more conscious about their health, monitoring them continuously. And it is highly required that in today's era, this competitive world and the stressful life, the health is the major asset to be looked forward. So why not the technology plays an important role by providing timely measurement or indications so that one can save and take precautionary steps before any serious thing can happen. So here, my talk would be concentrated on wireless body sensor network. Now, one would ask that why, what is the difference between a body sensor network and a normal wireless sensor network is? You are already getting so many you are already going through many expert talk which are related to the sensor network with a very precise way. But wireless body sensor network is one which is a major hotspot of today's research, where even medical fraternity is continuously working on this particular field of research. So here I would like to say that wireless sensor network, what we know is nothing but the joining the nodes and having some data transformation and transmitting to the other external server where the decision making is there. So sensor have become a new kind of input to our technology, right? So it is almost nearer to the human sensing. It is like that the human sensing thing is to be converted into the technology, and how it can take the information, and according to that, that information can be processed further for the severe or fruitful decision making. So we know that there are multiple types of sensors are available, multi-dimensional sensors are available, right? But how many of them are basically utilized typically for the human? Because sensing can happen in any kind of situation. Maybe it's a machine based, yeah, health based, or other way, security purpose. There are many types of sensing are available, and yes, it is a part of IoT itself. So I can say that body sensor network is nothing but it's a part of wireless sensor network, which is very precise to the human body. So as per the IEEE 802.15, the definition, if I would say that for this, that a communication standard optimized for low power devices and operation on, in, and around the human body, but not limited to the humans, to serve a variety of applications, including medical, consumer electronics, or personal entertainment and other. So it is basically covering many things like low power device. That's a very challenging scenario to develop such kind of devices. Similarly, such devices, or you can say these sensors, can be put inside the body, on the body, or around the body. So according to that, the overall body sensor network basically created, right? So that is what I just wanted to highlight, and I'll be going through that part, that how these categories, or how many types of sensors are there, and how the overall body sensor network can be created. So a very basic comparison one would know, one would should know that wireless sensor network and the difference between these two body sensor networks. So very first thing comes into the mind, that is the network deployment. So wireless sensor network basically is related to the environment. It covers a larger area, maybe in meters, kilometers, likewise, and the number of sensors, you can say they are very huge in it. But if we talk about the body sensor network, then here it is around the human body, right? A very few nodes are there, and other than that, the accuracy is a major concern in the body sensor network. Wireless sensor network comprises of huge amount of sensors to be deployed. It's something like, let me give you an example with this. Suppose we need to measure animal movement in a particular forest area. So in that, we are not going to personally visit the area. So what the application says, that we just distribute the sensor, or we just throw the sensor into that particular area of forest, and then it start working. So the idea here is that the throwing the number of sensors doesn't, we don't care about the number of sensors here, because it's a huge area to be covered. and the life of such sensor node it's totally unpredictable, because they are not accessible every time. When we talk about the body sensor network, they are basically lying normally lying onto the human body. They have to be low power, and they have to be very, very accurate, because medical is a field where any chance related to the human health cannot cannot acceptable, right? Other is the attributes. So here, if you see that here in WSN, I mean, the same function and same properties are there. So once you are deploying them, it is fixed. You cannot change, you cannot modify anything. That kind of situation doesn't happen with the wireless sensor network. But if you talk about the BSN, then in that you have different specialized sensor network, maybe for blood sugar, maybe for pressure, then other accelerometer, then movement. So there are many varieties which are available with the BSN, right? And even these BSN, I mean the sensors which are there onto the body are basically having the variation when it is moving, because it is lying onto the human body. So as and when the human movement is there, the sensing capability of this sensor becomes challenging, and that is why body sensor network is a very challenging scenario compared to the wireless sensor network. Battery powered, of course, that both are required, this battery input. And uh, where in WSN you can deal with the solar based power, but here in the BSN you have to have a minute battery, so it gives you a comfortness while the human are wearing it. And the data transmission, of course, in here it can use almost yeah, it can have almost all kind of you can say the protocol which can be utilized for the communication, because it requires some long distance communication as well. While in the BSN it doesn't deal with that kind of thing, because it requires a nearby communication, then it is transferred to the higher end. So while the sensors are communicating to each other, according to that the protocol or the stack has to be followed. So here, this slide basically gives you the hint about the data rate and the power which is supported. So we can easily see that body area network. See, there are many names basically related to this, like body sensor network, then body area network, right? Then variable network, variable sensor network. So kind of synonyms are there which are there in the research community. So here, if we see that body area network basically deals with very less power, and even it supports very less data rate too, because it is not giving you a long distance. But if there are certain kinds of sensor which are coming up, if it is inside the body, then it works on a sub gigahertz frequency. So if the sub gigahertz frequencies are there, it can provide the higher data rate. But the limitation that is in terms of the power that it works, right? So the transmission distance of that signal becomes very, very challenging in that scenario, right? So this is other way to represent the same thing, that how the body area sensor network, then interbody network, then internet and intranet are working together, and according to that the overall power and the data rate basically varies. This is much important, because what kind of data the sensor is collecting and transmitting from one end to the other, that communication in the body sensor network has to be very accurate, and in that any glitches cannot be accepted, because it can result in an accident too, related to human or any person who is under the observation, right? So overall, if you see, your body sensor network is having different kinds of sensors which are located onto the body, right? And there is always a sync node, so and there are source nodes. So the different nodes basically capture the information for what they are deployed for, maybe like blood pressure, as I said, heart rate, breathing, ECG, temperature, movement, proximity, likewise. So all these are need to be communicated and ended to one sync node, and this sync node is communicating to the external world, right? So because we can't create every time that every node will communicate to the other one. So it depends on that what kind of structure in the BSN is being applied. Right. So the very first important thing to understand is what is architecture of BSN, right? Body sensor network. Okay. So architecture of BSN divides in three major things: tier one, tier two, and tier three. Tier one is what? That the sensors are located onto the human body, right? And they are interacting to each other and conveying that information to the very nearby devices, maybe like mobile or laptop or any another displaying device. Now, after reaching that device, the result or the measurement data to the tier two devices, then it is transferred to the tier three, or maybe the onto the internet, or to the servers which are located far end, right, where the direct sensor cannot send anything. So likewise, your body sensor network is divided, the overall architecture divided into the three tiers. So we will be seeing all these like in a sense that we'll be concentrating onto the tier one part, and to the near that how the network architecture is basically working, right, and what are the typical application and how the people have worked for that. Okay, so very first, what is sensor node, which is supposed to be deployed onto the body of the human, or who is under the observation. So sensor node is responsible for what? Processing information by format conversion, logical computing, data storage, and transmitting. Now, these all phrases are very simple to read, but they are not actually. So when it is to be implemented, processed, then the complexity related to that gets started, right? So processing information is what? That what kind of information you are collecting from what kind of sensor. So the sensor classifications are there, which are based on the signal that they capture, or the work for, or the sensing what they are meant for, right? Similarly, the format conversion means what type of data they are collecting, because every time this what you can say, the data format conversion in any of the field is very important, because if the conversion is not available in a global platform, or on a global platform, or as per the global standard, then it is very difficult to work with such kind of data. Then logical computing, of course, because it is required to take certain decisions, right? And for that, you require a processor which basically handles such data, measures, compare it with a threshold, and see whether any any emergency is required, or any emergency had happened or not, or according to that, whether the further processing is required to that or not. Even the data storage is required, because it is a continuous monitoring part, and then the transmitting to the tier 2 or tier 3 part, right? So this is how basically it look like, that your sensor is one sensor node is comprises of this thing: what? The sensor modules, then processor module, then wireless communication module, and the power supply module. These are the basic modules which are there in one sensor node, right? So overall, these are the sensor node which are basically deployed onto the body, or require as per the requirement, because every node cannot do the transmission and reception and processing and all. So it depends on the application and the type of sensor module that is being utilized. So sensor module, what it does, it measures the data, collects the data, right, and converts them into the electrical signal. Of course, suppose if you are doing the soil measurement, so it is going to have that wet content and the dry content. If you are measuring the blood, then it is going to identify the the oxygen level. So likewise, the performance of the sensor is different as per the application. The processing module, it controls these sensing nodes, that what sensor has to do or how it has to work. So the controlling entity will be the processor. Then you have a wireless communication module. That is very important, because every time with such kind of small modules, we cannot deploy the wires, right? Or we are not going to wear the wires all over the body. So here the wireless transmission is highly required. So for that, we have to have your network layer, MAC layer, and the wireless transceiver, which is with the physical layer, right, and responsible for the communication among the sensors and with the external network where the sensor are communicating, or it is gathered at a central point. Okay, and of course the power supply to allow everyone to work efficiently. Okay, so these are the basically look of one or two sensor module. Just as an example, I wanted to give that the size matters. Size gets different. So if we talk about the body sensor network, so they won't look like this, but it's a normal architecture of a sensor node which comprises the things what I have just discussed, right? So the point here is what are the types of sensors? So the classification of these sensors are in variety. Why in variety? Mm, because the type of sensor that we use, the application for which the sensor is being made. See, basically, what is a sensor? If I, in a very simple manner, if I say sensor is nothing but it is a kind of an antenna, right? So it is going to capture certain kinds of signal variation, whether it is contraction or expansion or pressure or wet or dry or oxygen or temperature. So all kinds is nothing but they are working on a particular frequency range, and they are trying, they are kind of antenna which is sensing this variation of that typical waveform or the signal, right? So if I say that what kind of signal that these sensors are capturing, according to that they can be classified in based on the signal type. So there are certain kinds of these sensors which are accelerometer, then gyroscopes, then ECG sensors, then EEG sensors, then EMG sensors, and visual sensors and auditory sensors. These are the sensors which are collecting some kind of signals, while the glucose sensor or temperature sensor or humidity sensor or blood pressure sensor or sensor monitoring this blood oxygen saturation, they capture certain kinds of situation. Now signals. Now what kind of signals? So these are the blue one which I have shown you. They captures the continuous time varying signal. So these continuous time varying signal are to be converted and processed further for the digital one, right? So they are basically working related to the real time signal acquisition, right? And here the power consumption would be very very high because it is a continuous monitoring. Accelerometer, gyroscope, ECG, EEG, they require to have a continuous monitoring. So it generates the continuous time signal and it requires a high power. So why we need to understand this? Why one should know that why what kind of sensor is to be deployed? Because these can be the limiting factor also while you are deploying any kind of sensor and doing anything. No, it cannot work like that. You have to select a typical category of the sensor. You have to see what is the power requirement, what is the coverage, what is the range up to what it can transmit. Likewise, the overall module gets disturbed, can be built up. Similarly, if we talk about the right hand side, the yellow one types of sensors, then here they gives you the discrete time varying signal. Okay, it depends on your physiology signals, right? So it's a variation is also detected. The temperature bada kam hua. So it is basically measuring the variation into that value. Okay, so humidity hai, temperature, yeah, glucose and blood pressure. So it detects them and it detects slow variation, right? A minute variation. Okay, because temperature variation is very sensitive, glucose variation is very sensitive, pressure, blood pressure variation is very sensitive. So the sensitivity of the sensor becomes of course important with respect to the application where they are applied. So here they are smaller, measure smaller quantity, works or measure the slow variation, right, and produce the discrete signal. Okay, and here of course due to the advantage of sleep, converting them into the sleeping mode when they are not active or not required to be measured or something or activated, according to that they can even save the power. So here the continuous measurement is not there, so that's why the power saving is a plus point to this, as well as it is just to send the data whenever some sensing is beyond the threshold. So likewise it can be utilized. So it is one way of categorizing the sensors based on the signal that it measures, maybe continuous and they discrete. Another is based on the transmission media, that what kind of transmission media they will be using. So one can be of wireless sensors, another is the wired sensors, and the third is the human body communication sensors. Wireless sensors, of course, we know it has to deal with the wireless media, It transmits the information through wireless media. So the challenges related to this wireless media is going to play an important role here, right? For that, they utilize majorly the Bluetooth, Zigbee, RFID, UWB protocols, widely utilized for the short distance and easy to configure. So nowadays, people are more concentrating on ultra wideband protocol for the latest research. So if anybody is interested to work on, they can go with that, right? Wired sensors are what that when the wireless is not possible or wireless is not of use, you can go with the wired communication and giving the wired connectivity among the sensors and the module, so it can transfer and receive the data. So but of course it is more stable than wireless, because wireless channels plays an important role. It is unpredictable, it introduces path loss and many other, I mean, interference and all that part can be a challenging scenario with the wireless scenario compared to the wire, right? And these HBC, as I was talking very initially, that now these human body communication sensors are works on a sub gigahertz frequency, so they can be integrated into the human body, and according to that, they transmit very less, or what you can say, signal with a very less power and for a very short duration. But as it is gigahertz, it transmits with the higher data rate. So that way you can have the communication from inside the human body also. So this is a new trend which is there into the research field of body sensor network on related to the human body communication sensors. Okay, here the sizes of these sensors are too low to identify, because if something is to be inserted into the human body, they have to be very miniaturized, so they should not affect any normal any functioning of the other organs which are there inside. Another is based on the position deployment, that where the sensor is being positioned onto the body, right? So it can be wearable sensors like outside, implantable sensors, and the placed surrounding the people, right? So wearable is very popular nowadays, because we know that the people are working on the clothes which are having the sensor itself, so the person can wear and walk and the measurement is there. But still, I don't know that how many of us have used those as a clothing sensor, right? So still the people are working. There are scope to work to come to the optimized solution to that. So here these variable sensors can be utilized for your temperature sensing, pressure sensing, right? And here size and weight of the sensor should be considered while it is designed. So design process is another factor which comes into the body sensor network, right? Another is the implantable sensors. These are to be such kind of sensors which is required to diagnose the affected area into the body, or maybe inhale it, right? Or it can have such camera which can give you the imaging inside of the tissues to the outside world. So the medical expert can work on that and help human to come out from whatever the problem they are facing with, right? So they are very tiny, they are non-corrosive and biocompatible. So such kind of precise sensors are very important and playing very much good role into the human medical strength. Then the place surround people, like we know that our elders are sometimes staying alone into some house, or somebody, or maybe your kid, you want to have a look upon it. So there you can deploy certain kinds of sensors which basically captures such kind of information, and you can get the information at your office or wherever you are located. So here where it goes that if somebody enters, somebody have left, or something like that. So such kind of measurement device parameters are there, where the sensors can be placed around the human, where to be observed. Right. Another is the adjustment ability. I mean, automatic adjustment ability. That is another category of classification with the sensors. So here, self-adapting sensors and non-self-adapting sensors. So self-adapting is what we know that it automatically get adjusted with respect to the order, method, boundary conditions, right? Statistical. So it basically gives you the optimized solution, but all sensors are not self-adaptable. So what kind of application the people are working on? So self-adapting sensors are very useful basically, because the sensors which are there in their fixed functionality won't give you a long duration of service, or you can say that once it is deployed, once it is manufactured, you cannot change it. So it always has a very limited time span of utilization. So instead of that, if a sensor is self-adapting, then it may adjust with the surroundings, processing, or do certain minute level of processing at its own end, can save the overall costing, as well as it can give a better result, or lifespan of the sensor can also be increased. If I talk about the non-self-adapting sensor, they are simple to design and need no consideration of self-adjusting function, right? So at present, these are kind of sensors which are utilized widely, like non-self-adapting sensor. It's something like, as I said, once a sensor is deployed, it is not going to be changed, its functionality, its sensitivity, nothing. So in that situation, once it is manufactured, the cost, the time, or the design is just one way or one time use. Instead of that, if people start working related to the self-adapting sensor, then it will be the future, of course, into the sensing industry related to the body sensor network typically, right? So there are many sensors in body sensor network. So here the list of these sensors are basically highlighted, where you can see they are categorized in terms of signal type, sampling frequency, and placement where it can be utilized. So the accelerometer, artificial culture, artificial retina. Yeah, retina is artificial retina nowadays. I mean, it is highly in. It is also more more catchy field of research, that if something is to be implanted into the human, which can change the overall performance or visualization or functionality of any human organ, is always challenging and very very impressive. So it is where the people are working. Then blood pressure sensor, camera pill is also there, which is utilized for the gastrointestinal tracking, for endoscope technique. Then carbon dioxide sensors, right? Then ECG, EEG, EMG, it's widely utilized and most popular sensors, I guess. Then gyroscope is on. I mean, there are many of the things which are available in our mobile phone, like gyroscope and accelerometer and all that part. Even the pressure sensors and all that. Even ECG, we can keep our finger onto the sensor, and it can give you the heart rate. I mean, such kind of sensors are by default existing nowadays in our mobile phones. The accuracy matters, of course. So that is the always thing, that how the accuracy of these medical sensors basically giving. Then blood oxygen saturation sensor, pressure sensor, respiration sensor, temperature sensor, visual sensor. So these are variety of sensors available, but there are always what you can say, the optimization is always there, because miniaturization, optimization, and the major part is the accuracy with such kind of sensors. So widely used sensors, as I already discussed, ECG, accelerometer, pressure, and respiration sensors are widely utilized sensors, and they are at present, they are at the top, we can say, but the other sensors are highly required to come up with. So what one should look, or what kind of criteria one should look while they are designing the sensor nodes, right? So the sensor nodes are basically see, only sensor cannot work. So you have to have a sensor node, then only the sensing is of use, right? If something like that I have developed that antenna, and if I have placed onto my body, it is not of use, because it is not able to transmit anything. It is not going to give me the detailing of what kind of content it is measuring. Then that sensor is of no use. So sensor alone cannot work. It has to have the other other thing around it, like real to capture the signals, acquisition of signal, right? So in order to meet this thing, also it has to deal with the low power consumption. It should have high flexibility, which gives you high variability, right? And with that, there are certain issues which is to be considered. like energy control, fault diagnosis, and reduction of sensor nodes, right? So design of nodes should meet these demands, like as I said, low power consumption, high variability, and they have to have a proper signal acquisition capability, right? So if we talk about the energy control, so energy control is what, that one has to design low power architecture design, low power processor design, low power transceiver design, and energy acquisition design. These are the phases where people can work. I mean, electronics engineer, VLSI design engineer, communication engineer, they all ASICs designer, they all work on this. Antenna designer, which basically deals with the good antenna for the sensor part. So these are the field where the people can work and try to reduce this energy consumption, where the efficient sensor can be built up, right? So there is a researcher who have given a programmable architecture for ultra low power consumption, right? So where it basically have ultra low, where it's a programmable one. So it is based on the dynamic time wrapping design specifically for a variable inertial sensor is proposed, right? So what result they got is, they got the power consumption level reduced by 3 times. So this is what that the people should work on. If we deals with the low power functionality of the sensor, high accuracy and lightweight, and the variability is going to take the body sensor network technology at the next level, or maybe at the higher to that. Similarly, another researcher have introduced a low power processor design, which reduces the supply voltage to below threshold. Below threshold is almost like very, very less. I mean, it is consuming so much of less power that the duration for which the overall sensor node is working can be like prolonged. So that is what required, because we cannot deploy this sensor on a frequent basis. Every time, if suppose a sensor is to be implanted into the human body, you cannot cut down the human body on a regular basis, right? So once it is implanted, it has to work for a long duration, and for long duration functionality, the power requirement is a major thing. Power conservation is a major challenge, because we can say that how once it is implanted, how to provide, or what way to manage that power supply to all over the thing is a challenge, right? So this is what the another researcher has provided as a low power processor design. There are many other researchers. I have not listed out all of them, just I have kept one or two, so one can get the idea that what are the research field or research topics what people can work on if anybody wants to. Then the fault diagnosis. What is fault diagnosis? So as I said, if we are deploying many of these sensors, right? So self-diagnosis of the sensor, I mean fault diagnosis is highly required, because we cannot go and measure each and every sensor which is placed, right? So the challenge here is that usage of these multiple sensors, right, can break down or broken down sensor may affect the failure of the overall performance of the system, or it can just disconnect the continuity of that overall nodes which are deployed. So this is highly required that it should identify. So what it does, or what could be the solution into it, right? That it has to have a comparison of a consecutive nodes data, right? Because it's something, suppose one or two or three ECG sensors I have kept, so each sensor is getting the data. So I should have a provision or algorithm in such a way that it compares the data which are being sensed by the consecutive nodes. So if the sensing is coming perfectly or similar, it is considered that the sensor is working correctly. Suppose that there is a fault where it is identified that that there is a variation into the measurement, then it is easy to identify that XYZ component or the sensor is not working. So according to that, whether that signal part is to be taken into the decision making or not can be decided. Because if we don't have this fault diagnosis into the body sensor network, then it may happen that we may consider the sensing of that faulty sensor, and we may take a decision decision for that particular human, which is not required at all. Okay, so the correct functionality of body sensor network, or the sensors which are utilized in the body area, or sensing the human health, is very very important. They have to work efficiently so that the wrong decision cannot be taken. Similarly, the researcher in the third reference have indicated that the detection accuracy decreases as the number of sensor nodes decreases, right? So as many you low number of sensors you are using, so the detection accuracy is going to reduce, because as many sensors are there, you have a comparison and you can see that whether all are working correctly or not. If suppose one or two are there, whom to compare, which one is correct, it's very difficult to decide. So it of course depends on the application where you are applying, but this is one way to avoid this fault alarm, you can say, or faulty detection into the sensing scenario. Similarly, the other challenge is to have, as I said, right neighbors for data validation, in order to reduce the false alarm. False alarm, as I said, the wrong detection or wrong diagnosis of the signal or the sensor part. And for that, another researcher have providing the option of using a sliding window technique, which which segment the data and compare each and every segment, whether the particular segment is working correctly or not, or giving the proper measurement or not. And according to that, it identify whether the sensor is working in a correct sense or not. Right. So it even has the subcategories into it. It can be have history based, or it can be have non-history based. Now, history based is what? That suppose this segment or the windowing technique, what is being utilized, the sliding window, it has the memory and it compare with that. And non-history is, it is just giving comparing comparison on a same instant or at the same time, so it can have a decision making at that time. So it doesn't depends on the previous data, but it takes the decision at the right time or at the real time. Okay. The third is the reduction of sensor nodes. Of course, it aims to improve what the variability of the behavior recognition system, lower the cost. Okay, if the number of nodes are higher, of course the cost is going to increase, because manufacturing cost gets increased as many as is to be deployed into the cloth or anyway other application. It saves energy. As the number of nodes are less, it saves energy. It simplifies the recognition process, that which one is working correctly or not, giving a proper result, accurate result. And also it reduces the data redundancy too. So overall thing, that the optimized number of sensor nodes are highly required, because it is impacting on these many factors: behavioral recognition, cost, energy, complexity of process, and the redundancy. Right. So these are the things. So here the principal method is what? The optimization of the node placement. If one is correctly placing the node where you don't need its duplicate or its what you can say, a redundant data, maybe one or two you can use, not more than that. So in that situation, you can reduce the number of sensors, but the placement of sensor node has to be correct, so that it can measure that particular information with accuracy. Right. Similarly, the other method is to improve the activity recognition algorithm, or you can have, or you can identify how accurately the variation or behavioral change of a sensor signal is being measured or recognized. So either you deals with the number of sensor nodes, either you deal with the processing part, that is what the recognition algorithm, which easily recognize the variation into the data, and it can take the decision. Right. So these are the thing which are considered into this. Another major factor comes into is the data fusion. So what is data fusion? I in between, if any question related to this, it will be easy for me to answer, or whatever you say. I hope I'm conveying the thing what I wanted.
Uh, okay, Dr. Shah, there are a few questions.
Oh, okay.
Okay,
Let
let
me
us
come
take
on to
it
that.
now, and then we will go to next part. Okay.
Yeah, it's fine. We can take the questions, no problem.
Okay, you can take it, or I can read it out for everybody.
Let me see. Question QA only. I would be having this question, right?
Okay, yes. Dr. A. Jeshudas requested for your presentation. It will
Sure.
be useful for us. Okay, you just send it to me, and I will put all the presentations into a Google Drive and share with everybody, so that whenever required, they can have access to it.
Of course.
Next question is from Dr. Jeet Banerjee from Amity University. His question is, kindly suggest some fundamental IEEE magazine journal papers to have a detailed study of the sensor shown in this presentation. I
Of
think,
course.
okay, I think already
Huh.
you were mentioning 1, 2, 3, 4. You have given the references. At the end, they will come. And before that, I must say, many have Dr. Rajesh Kumar Jain has but not a question but a comment that excellent presentation. Then so till now, these are the questions or comments what we came across.
Fine. Fine. Sure.
Next, at the end, once again, we will proceed. Thank you very much.
Okay. You let me know whether you are able to see this presentation slide right now. Data fusion.
Yes.
Okay. Okay. So the next point to be discussed is the data fusion. Now, what is data fusion? As I said, that it's a process of handling multiple data which are coming up from the multi-level sensors, right? So they have to be multi-faceted processing to make data more effective and meet user needs better. Blood sense, suppose it's something like a variable sensor is what where you can place variety of sensors, so all of them are actually taking different kinds of data. Now all these different kinds of data are to be fetched together to the sync node, and from the sync node it is going to be transferred to the external world, right? So that the data fusion should be very very accurate or precise, so that it won't affect the data of the any another sensor. Otherwise what will result is it is going to give the wrong result or wrong indication, and it may end it with a non-performing output, right? So here the data manipulation happens very very easily into the sensor node, right? So data fusion technique combines the data from multiple sensors, filtering noise, achieve more accurate interference compared to your single independent sensor. So data fusion, if you apply, it can handle avoid noise, because what is noise, what is interference, we people very well know, because whenever any signal travels through any media, it is going to get affected by the channel or the media through which it is traveling, whether it is wireless, wired, or human body communication media. So data fusion helps to clean the data, so we don't work on the unwanted part of the information. Even at the same time, it reduces the data redundancy, reduce the load and energy consumption of these body sensor networks, resulting in a long life of the network, right? So here we can say that all type of data cannot be fused even, right? Because we saw many classification of the sensor, right? So certain data are such that they have to be work independently, and certain data it is possible to have the merging or data fusion, right? So if you see like blood pressure, body temperature and heart rate, they are not required to be fused, they are individual entity to be observed. But if you talk about in terms of like some pulse wave, maybe at here at the top of the body or at the bottom of the feet, where you have to measure the different like fluid which is going through the body, where multiple sensors are located. So all these multiple sensors are going to collect those data, and the fusing is possible, right? So certain cases are there where the data fusion is required, and certain cases are there where the data fusion is not required. So it depends that where we are applying that. Okay, so the data fusion is in general is a combination of pre-processing, feature extraction, data fusion computation, and data compression. So what is pre-processing? Any signal has to be pre-processed. Now what is pre-processing is, pre-processing, if you see, it is the cleaning the data, from noise, interference, and for that many signal processing algorithms are already existing, like wavelet based Fourier transforms is there, linear representation is there, high pass filtering, low pass filtering, then morphology filters, Laplacian, Kalman filter. These are the varieties of pre-processing which helps to remove this unwanted part from the signal. Then comes the feature extraction. What it does, it basically gives the features for what the sensor is being deployed, and it just fuse that data, whatever the information, whether it's temperature, pressure, or oxygen level, whatever, it is to be fused or given to the computation method. Now what is, why computation method? Because computation is basically gives you the idea that what decision is to be taken. So for data fusion computation, it requires different types of classification algorithm, right? It has to classify what kind of data it is, discrete hai, continuous. So likewise, it has to identify them, and for that there are different methods available, different algorithms available, like hierarchical methods are there, decision trees are there, Bayesian network is there, then hidden Markov model is there, then artificial neural network is there. Of course, the whole era is going towards artificial intelligence. So of course, why body sensor network will not be using it? So ANN, of course, artificial intelligence, neural networks can be used here, which gives you more intelligent outcome too. The last one is the data compression. Data compression in total is going to reduce the data, so that why reduce the data? These data compression has to be lossless if it is medical related sensing, because lossless data will give you the accurate data, and according to that only the decision can be made. So there are many encoding methods are available, and that is widely and most popular encoding techniques are also available. Now the other thing is design factors for communication, right? So what are the design factors? That it's something like, um, what is the range of the data, suppose, what is the feasibility of it, right? These are the other parts which are also to be taken care of while one is working with the body sensor network. So the design factor is what, that these nodes are not bounded with the wired power, right? So the very major constraint is the long time operation with wireless communication and with the very least power. So nodes are designed as small as possible, right? So it cannot be, or it should be feasible to wear. So one of the researcher, Benny, has given the size of 26 mm size of sensor. I mean, you cannot, it's very easy to wear, right? So what happens as you reduce the sensor size, of course the battery capacity is reduced. So as the battery capacity, the power backup what we are giving to the sensor, if it is reduced, so the performance, right, of the power supply is also going to be limited. So in that situation, the lifespan of the sensor is challenged. Of course, this miniaturization is going to cost, so the least power consumption is a requirement. Also, it is possible to adopt the energy acquisition technology. I mean, it can have, or it can take the energy from the surrounding electromagnetic environment, where you can increase the power capacity and the lifespan of a sensor, right? So we know that wireless wire transfer or power transfer is another technology where the people are working. Similarly, with our body also, we have the energy. So one energy is to be converted into the other energy. We do have the body era, we can say, where the research is going on related to the brain computer interface. It is a kind of the minute signal which the brain is generating and capturing it. Similarly, the certain kinds of other signals are even surrounded to the body. So why don't we use the information of those data, or you can say the power of those data, to work with such a small amount of power? Okay, so without the power, the BSN will not provide efficient functionality. So whatever advanced level of sensor you make, but if the power is not there, your sensor is not going to work at all. So power management is highly required in the sensor technology. So therefore, the network architecture and the protocols should guarantee that nodes should complete the data transmission of highest quality with the least power consumption. So I have underlined this typical sentence because it is conveying so many important factors on which today even the research is required to be made, right? First of all, high quality, right? Data transmission, right? And the less power consumption. So these are the three major factors where the sensor researchers can work and contribute more for the community. Okay, so very first comes into the radio range. So this band basically giving you the hint of application of generic band and the medical specific band. So where the inductive implants are utilized, implants are there, telemetry is there, and many other subband frequencies are defined with this. So radio range, we know that due to the miniaturization, what happens is the energy conservation is there into the design. We have to converge or we have to conserve the energy. Okay, and with respect to the ultra low range transceivers, it can range up to zero point 0.2 to 1 meter or maybe 0 to 1 meter. Different transmission ranges are available as per the antenna or the sensor capacity. Okay, so the smaller the transmission range, what it requires, more careful the network topology design should be, because because if it transmits to the very less distance, that communication had to happen up till the last end of the sensor product. Okay, so if somebody is transmitting and it is not reaching to the end, there is no meaning of that communication. So here the communication topology and the protocol, they are to be considered in a very intelligent manner. Another is the path loss. See, path loss is what any signal which travels from one end to the another end, it has to face path loss. It can be in terms of attenuation majorly, or can be in terms of interference or noise, right? So here the body shows that there are many sensors which are located onto the body and they are connected to the sync node. So while they are transmitting the information from the sensor to the sync node, due to that travel, even if it is wireless, due to, or if it is wired, due to the travel path, it is going to face the path loss. So path loss models for body sensor network are also required to be designed very efficiently, because what is the advantage of path loss model is that they basically gives you the prediction, or you can say the behavioral idea, that how such kind of channel through which the signal is traveling from one end to the another end is going to affect. So if that is approximately known, then it can be reversed at the receiving end and it can be repaired, and that way you can increase the performance. So path loss is another factor which is required to be considered while designing these things. Third is the strong reliability, because these are the variable things, right? Variable device. So if it is used and if somebody is like fallen, or it gets pressurized with some external force, it should not get affected. Other than that, it should give you a proper result. I mean, in any condition, agar apne, I mean, if the sensor is being there, suppose the example is given as a fault detection application. So if the sensor is reliable, everywhere it is located onto the body, suppose it is meant to detect the fault detection. So if a person is falling or fall, so at the same instant, it should give the indication. If it is giving the indication after 5-10 minutes, there is no use, because the person is already fallen, and whatever is to be happen may happen to that person. And in that sense, there is no sense of using this sensor technology. So the reliability of transmission of data timely is highly required, and almost it should be near to real time in many of the applications related to the health. Okay. Another is the security issues. It's of course major issues, because nobody would like to, nobody like to get highlighted, at least in terms of their health, right? People are cautious about their health security and health related information. And as we are using wireless media, so it is always a possibility that nearby network or the signal or the receiver which are available may capture some of the information. It's a simple, right? Even our mobile phones are having the sensors. Okay, so when we are traveling, or when we are connecting through Bluetooth or Wi-Fi, so if such kind of intruders are there who can collect those information, then the security won't be there. So the algorithm with respect to the security is also of concern in the body sensor network. Okay, another is the major thing is mobility. See, the sensors which are deployed in a static environment, or once it is deployed, no need to move, no need to be affected, something like that. In that situation, it becomes very, very easy to manufacture such sensors and deploy such sensors and work with such sensors. But when the sensor is located somewhere onto a surface which is moving, right? So its orientation, its inclination, its penetration, everything is going to be changed at any point of time. Now, these variability nature making wireless body sensor network more complex compared to the normal static sensor application or wireless sensor network application, which is utilized in farm agriculture or in water measurement or soil measurement. They are just deploy once and forget it. It is going to work, as the foil is not going to jump or not going to work like anything. But here, with the wearable devices, they are having a challenge with respect to mobility. Now, with mobility, if the penetrated devices or located devices or the placement of the device, it gets changed, then it is not going to give you a correct result. So that is also a concern or challenge in the BSN, that the sensing what is being done has to be very, very accurate. And that's why the delay tolerant network are there, which are giving the routing protocol in an intelligent sense, so that it can connect with that broken signal, rebuild it, and continuously working. It's something like a sensor is connected here or somewhere else, and due to the movement or some lying down or like sitting and standing, the location of that gets changed. Now, due to that, it may happen that it affects the communication link to the sync node. So when it come to the original position or some due to the movement, it should get reconnected, and there the routing protocol key, how the link has broken, through which sensor it is not connected, it can be rebuilt. So certain kinds of the scenarios are also required to be worked upon in the wireless sensor network. Okay, now we are moving towards the network communication. That what are the protocol layer basically important in the body sensor network. So in the network communication, we can have characteristics of BSN, which is quite difficult compared to the normal WSN, as I said, that it can affect the electrical characteristics of the body. It can influence through the radio communication, right? It can have frequent changes of the network topology, mesh, yeah, star or bus, likewise, right? So, and somewhere it may require to have a cross layering as well. So the major communication layers which are useful or which are important to concentrate are the network topology, physical layer, make layer, and the routing layer, right? And at the sometimes it may happens that due to non-availability of that, it can have a cross-layer protocol availability also. So it may skip some of the layer and can connect it to the other higher layers, so that the communication lasts and the functionality of the sensor never dies. Okay, the network topology, we people are know that it basically deals with the performance features like power consumption, traffic load, node robustness, selection of MEC protocol, and routing protocol. So there are varieties of topologies available, but the major are star and the mesh topology, which are easy to work with this, right? And other are very complex and dynamic, which won't work with the body sensor network. So if I talk about these two topologies with respect to the recent parameters we have seen, so what happens if we use star topology and the mesh topology with respect to the path loss? So what happens here in star topology is, if the nodes are on the same side, it has low path loss, but if they are at the different sides, they have higher path loss. But if you talk about the mesh topology, then there is a reduced path loss, right, due to the diffraction and the multiple hopes. Radio transmission range, if we talk about it, for that, the star topology is not suitable for small radio propagation, while the mesh topology gives you the range by changing the number of nodes and just get connected. Energy consumption, of course, the nodes closer to sync consumes less power in star topology because it has to travel very less distance. But here, the nodes who are near to the sync node consumes more energy because it has to carry forward the data which are coming from the different sensors. Sorry. Transmission delay. Of course, here sensor connect with sync node directly. So take the least possible delay in transmission. While here it can have little bit of intermediate delay. Then inter-user interface, if we talk about here, the farther away from sync node need higher power to transmit more data to, so more interference to the other nodes is possible. But here it transmits it to neighbors and the energy transmission is low and hence the smaller interference is there. And at the end, node failure, what happens in the star topology, if only the failed node is affected and the rest node network works well. Well, if we talk about the mesh topology, if it can give you the whole failure of the network because they are interconnected. So if any node gets failed, it is going to disturb the whole network. So which topology to use, it depends on that what parameters are there, what application is there, and what kind of sensors are being utilized. Okay, another, if we talk about the physical layer, it's basically responsible for encoding, decoding the signal, preamble generation, then remover of synchronization, bit transmission, reception, and specification of the data transmission, right? So it has two major area. Physical layer is what, that how the two nodes are connected and how they are transmitting the data bit, right? So there are two parts in it. One is the channel selection and another is the channel characterization. Okay, so channel selection is what, basically these many bands are available. So major physical channel, it's a frequency, right, or the medium through which it is going to change. So here you can see the HBC, narrowband, and ultra wideband. These are the major three bands, and these three bands are basically subdivided into the some other bands, like narrowband in MICS, WMTS. I'll show you. So first is the human body communication band, which takes human body as the data transmission medium and is only used by BSN. No, any another application can use it because it is basically meant for human body communication. Its primary technology is electric field coupling. It can have capacitive coupling, it can have galvanic coupling, and through that coupling, it gets connected to the other device. Similarly, MICS is the medical implant communication service, which has the transmission power of up to 25 microwatts and one of the communication bands suitable for very low data rate network, right? Then comes the WMTS. It's a wireless medical telemetry service band, which has B, C, D, E. Other bands are also there, used for telemetry in hospitals and all. Then F band deals with 2.3 gigahertz medical band, of course, which is newly approved by FCC in US. ISM we are already know, it's a open band, industrial scientific medical band, works at 2.4 gigahertz. Then UWB, it's have a great advantage in upcoming BSN. As I said, the UWB is one of the promising protocol what the people are working nowadays, right? It provides the these low probability of jamming and interception, and it's a most robust technology which can be utilized with the higher data rate as well in the low power. So it has a best quality of all the things what is being actually required with the body sensor network. Now, channel characterization is basically nothing but the estimation of delay and reducing the path loss. That what channel has to be used or efficient channel is to be used, right? So there are certain three common channels methods are there. One is the measurement based method, which gives you the average path spreading gain, large scale attenuation or small scale attenuation. Then simulation based, where you can use finite difference time division methods and do the analysis. And another is the combination of these two. So this basically gives you the characterization of the channel, that what way my sensors are going to travel, what channel variation it can have, and what precautions one can take later. Third one is the MAC layer. It is basically to achieve maximum throughput, minimum delay, and to maximize the network lifetime, right? So it controls this with respect to the source of energy waste. I mean, collision, it doesn't allow collision, so the energy can be saved. It go with the ideal listening, overhearing, and packet cost. So all are the part of this MAC layer. So it has three protocols major. contention protocols, schedule protocols, and the contention schedule protocols. In contention protocol, you must be knowing CSMACA. It's a very wide popular protocol, which is like utilize when to transmit, what to transmit, and to avoid the collision. Right? Schedule protocol will give you a time-based TDMA-based technology where, with respect to the time only, the data can be transmitted and received, so the collision can be avoided. So it is one of the protocol which is utilized in the MAC. There are other distributed queuing, medium access, HMAC, WHMAC, body MAC are based on TDMA, which are done or which are produced by many of the researchers. Then contention schedule protocol, it's a combination of these two that you can have a best matching among the algorithm based on TDMA or CSMACA and can come to the result. The fourth one is the routing layer, which is basically the addressing, you can say, which sensor is sending and whom want to transmit. So it's an end-to-end package delivery in BSN. It tries to solve unbalanced energy distribution and topological partition problem. Now, what is unbalanced energy distribution is that when it is running, the part of nodes consume more power and some may consume less power. So here the unbalanced energy distribution may happens, right? So as a solution, what it does is it applies the heuristic self-adapting routing protocol and do this energy balancing. So with respect to that, it identify the parent node automatically and do the or apply the energy balancing. Similarly, it helps to reconnect the disconnected nodes and minimize the network transmission delays. So if somebody gets disconnected, it tries to reconnect and it keeps the link on so that the delay can be reduced. The another one is the topological partition, where the body movements will cause frequent partitioning, and disconnection in BSN topology. Here, they have they aggregated in by ultra short wireless range due to its variable design. So to solve it, it use probabilistic packet routing mechanism. So based on that, it can handle this topological partition problem, which depends on the postural trend of the human body for which it is being applied, and according to that it gives you the probability of this packet routing situation. So these are the thing where the people can work like in a tremendous way, can provide many of the solutions which are still not solved in 100%. So these are the other algorithms I have just kept it as a list. One can look further if anybody wants to go ahead in this. Okay, the cross layer is what? It is the effective way to improve the performance by compressing or adapting the redundant information across the layer and module. So sometimes, as I said, it gives the convex optimization or artificial intelligence way to utilize the resources available into the wireless network. It provides better quality of service, right? It can have cross layer dynamic source routing, and it can have other controlling access with distributed slot assignment. So these are the feature of the cross layer which can be utilized in some of the situation wherever it is applicable. Now we are moving towards the applications of BSN. So there are many of the application, but few I would like to highlight very quickly so one can visualize that. So very first, very most, or you can say popular, is the medical field, where cardiac based ECG signal monitoring, right? So the researcher have identified the planar fashionable circuit board, PFCB we can say, which is printed on the clothes, right, fabric, and it can be worked without having any skin irritation. So you can see the figure where this sensor is being designed on a fabric itself. It doesn't give any reaction to the body, and this is how the ECG signal can be measured with this PFCB sensor. Another is the suggested by having integrating all these sensors in one plaster. So by instead of doing this individual sensing or fabrication, one can have a direct you can say a combined smart politic sensor which is in a same plaster, and it can be integrated and improves the wearability or comfortness of a person to wear. Then the third is the Parkinson disease monitoring also is there, where the behavioral recognition, that the variation or the shaking, all that part can be easily identified and monitored by the sensor, right? So people have designed such sensors also, which helps to, the person who are suffering from this Parkinson can improve their health, and monitoring as well. Emergency medical services also can be provided. Another kind of speech signal processing based also algorithm have been suggested for the Parkinson sufferers. Like you can see that based on the speech variation, also it is possible to identify whether the person is healthy, subject with Parkinson disease, or something like that. The other is the lung disease by integrating the sensor on a t-shirt, where the variety of these sensors are fabricated in a very fashionable manner, which is very comfortable to wear. But with that, it is providing you the health monitoring in a very efficient manner. So this is another application what the people have worked. Another is the mobile health or M health, which is a new direction to the BSN. So here the ECG sensor, accelerometer, temperature sensor by an Android phone works as an aggregator. Here, if you see, this is where the existing of these M health is working on. People are more towards this. They are, because mobile is a device which everybody owns. So it's, if such kind of service is available with it, it makes the life more easy and more safer in terms of medical. Then another application in terms of social welfare, where the electronic system can help for a long-term monitoring of like patients, like disabled, elderly persons, then children who are staying little away and requires a proper monitoring. So this is one of the very well-known application that we people are work, or we already know. Just for the sake of application, I have kept here. Another is the social welfare in terms of the human body posture conversion, that like wearable inertial sensors to predict fall actions, right? So the typical, you can say that the falling of the person can easily identify if somebody start falling or may about to fall or something like that, right? Similarly, people have work related to the wearing airbag incorporating a fall detection. So these are the variety for one particular challenge, fall detection, right? People have given a very good solution where the which help humans to maintain their posture. Sometime nowadays, if we see, our kids are always having with the mobile and giving a bad posture, so you can even apply a sensor onto them that okay, your posture is right or wrong. So because at the later age, see, the posture, incorrect posture at the later age is going to affect the human overall body performance. Okay, another is this ear-worn activity recognition, EAR, predicting the risk of falls by gait and balance detection. So it is something new which we have not seen in previous two examples for the fall detection. So innovation have no limits. So people can think that from what kind of angle we can see that the person is having fall or likewise. Then the sports, of course, to improve the performance of an athlete, body sensor are playing tremendous role. People are identifying the gaming pattern, the force, what a particular sport person is giving, or what style it is, swimming, or what speed it is running. So kind of the application are very, very useful in the overall athlete performance. So one of the example is the multimodal remote sensing platform called Tennis Sense, which gives you the way the people is playing the tennis and trying to detect it. Then kinematic analysis of swimming stroker, that what kind of stroke it is giving, whether it's a correct one, whether it is not correct, what level of improvement is required. Everything is possible to analyze with respect to this technology. So it's very, very useful for the overall improvement in the athletes' performance too. Similarly, perform framework for the use of inertial sensors as a low-cost footing coach or for a goal. I mean golf. So that is, in the golf also, it's like the people are using the sensor. There's a design a sweat pH monitoring, that you can measure the pH, and also there are variety of applications available. Similarly, you can have a man-machine interface where you can help deal with the traditional man-machine interface, like in terms of keyboards, mice, joysticks, touch screens, and all that, right? So one is the intra-body communication, IBC application, right, where a shoes is carrying so many sensors, right? It can give the voice command to a blind person, so that a person can walk easily, can move around as good as normal people. Similarly, there is IBC enabled eyeglasses are also available, which helps the deaf people to live their life in a very normal way. There are hand gesture based gloves available, which helps the disabled people who are not able to speak or hear, can, with respect to the sign, can basically understand and communicate to the normal people. So it is one video. I mean, just to give you a hint, that I'll give you this.
Hello, you are not audible. Madam, you are not audible. Hello, you are not audible. Hello, I cannot hear you. We cannot hear you. Just once again check. Hello. Can you do one thing? I'm calling you and making my microphone phone mic in the speaker mode so that everybody can hear. I will pick up the question and thereby maybe probably we can solve the issue.